IB Physics questions, DN95. An object of mass m is accelerated vertically upwards by a motor at a constant acceleration. The object is initially at rest and reaches a vertical speed of 4 meters per second in 2 seconds. What is the average power output of the motor? Alright, well, there are multiple ways to go about solving this. One of them that is likely most popular is that power is equal to the change in work over the change in time. So we have the change in kinetic energy plus the change in potential energy over the change in time, which is just 2 seconds. And then you can solve for kinetic energy and potential energy individually. But then you're going to have to solve for height and all that stuff. I think the more easier way to solve this question is to consider P is equal to force times velocity. Now we have to be careful here, actually, because this is usually used, or it requires the condition that velocity is constant. But if we consider each of these values to be average, we can say that the average power is equal to the average force times the average velocity. So this here is true, and we can use it in this case. So first, let's go about finding this average velocity. We know that we're going from a starting velocity of 0, because it is at rest, to an end velocity of 4 meters per second. So since this is under constant acceleration, we can say the average velocity is 4 divided by 2. So now we have 2 times the average force. Now, the force is acting on this object. We have weight acting downwards, mg, and then the force applied from the motor, let's consider that magnitude to be x. Now the net force is going to equal to ma. These are not balanced. X is greater than mg because we're moving upwards. So we need to find the acceleration, this constant acceleration. And acceleration is equal to the change in velocity over the change in time. The change in velocity, well, 0 to 4, means the change in velocity is 4, and the change in time is once again 2, so our acceleration is 2. So force net is 2m. Now, we can also write force net as x minus mg, and force net is what we just found, 2m. So now, to solve for x, we can add mg to each side. We're going to get x is equal to 2m plus mg. And consider g to be 10. So we're going to have a total of 2m plus 10m, which is 12m. So the the force supplied by the motor is 12m. So now we go back to our power equation, and we have 2 times 12m. So our answer is going to be 24m. That is answer choice B.